Hello.
Hello, Jerome. Thank
Yeah,
you for
my
release
power just went off of my house.
55. It works.
What?
Thank you for release 55. So environment
Oh,
mechanism working fine.
yay! That's good. Um, oh, by the way, these meetings are recorded and published directly to YouTube. I knew that they were being recorded. I didn't realize they were published directly to YouTube and I have it automated.
I guess.
Uh,
Hello, Kiss.
oh, Keith, I was just saying I found out I knew that these calls were being recorded, but they're also published directly to YouTube. So I didn't
They are, yeah, yeah,
realize
yeah, yeah.
that.
Yeah, I mean,
Just,
but we
I'm
should
gonna,
still have, we should still both still, that shouldn't, in most cases, shouldn't limit us from having these discussions. But yeah,
well, no, but yeah, like certain things we could just like take offline and it just depends on what it is. So obviously,
yeah.
just a moment. I'm gonna mute myself because some of my family's talking in another room, and I'm gonna go grab a drink.
Okay.
Okay, looks like it's just us. It's 5 minutes after. I'm not sure how long I'm
Wonder
gonna wait.
maybe I wonder if I doubt anyone else is going to join. I wonder if I could share some stuff I'm working on and just get your guys' feedback. Or did
Do
you have another
you
topic?
want to just? Well, we could. I mean, depending on what it is, and then we could let Alex go, and then you and I, you could just send me a Zoom link, or I could send you a Zoom link. We could.
I was
I just
hoping
don't
Alex
know
is.
if we will record it in YouTube.
Yeah, it's fine.
Oh,
Again,
well,
all this is
I can
public.
invite Alex too.
Yeah, yeah. I was hoping to get
I
Alex's
just don't want to
opinion
waste
on this
anybody's.
one.
Okay, let me look.
So I've been working on a let's hope it's up. Sorry, just give me one sec. Um, here we go. So I've been working on like a benchmarking suite for Solo. Can you guys see my screen?
Looks great. Yes.
Yeah, I mean it's just AI stuff, but like, bas basically, my goal of this project was to take a look at the performance of Solo and how it, and what it and how how specifically how it looks against local node, but it's also just like monitor the performance and some key metrics for Solo. So, it looks at things like first run startup. That means like, and there's some definitions here, like what that means. Um, Shutdown time, restart time. I don't know about this full reset time. I might get rid of that. But the other two things I came up with, and I think that this is where I could use Alex's input and help. I tried to create two tests that basically tested if you want to use the test run performance of Solo. And the way that I did these tests, and I think maybe I designed them incorrectly because they're not giving me the time. They're not, it's not ex what I expected. So basically, in these tests, like if you take the happy test, using the SDK, I like create three accounts. I deploy a smart contract. I create a token. I mint a token, and I transfer a token. And like that's the end-to-end test, and it takes about like 8 seconds. And then for EVM, it's very similar. It's just like it's doing the same thing, like creating three accounts, deploying a smart contract, an ERC smart contract, minting a token, and transferring a token. And, it takes longer for this. But also the way that I designed the test was that, because specifically what I think I'm trying to measure is the time it takes. I mean, the biggest thing about these tests is the time it takes for, like, you submit a transaction and for the time it takes to hit the mirror node. So basically, like, I'm actively polling the near node for when the data appears, and the test is sequential. Like, it only does one transaction. It does a transaction, it waits for it to appear in the mirror node, then it does the next transaction. So I guess my question to the team is when we're evaluating Solo, um, is this like the right way to do it? And then I guess the other thing is like because I'm on a Windows computer, I am having tons of problems trying to get this to work between the WSL2 environment, and I don't know, it's just port errors left and right and everything. But I mean, I wonder what you guys think about this methodology, and also specifically about like what is the best way to construct the test that basically analyzes the run performance of
Sorry,
Solo.
I lost you a bit, and it's on my side because my power's out, and then whole in the whole area, so everybody's hitting the same cell towers, and so um, trying to get this image probably and the audio is a bit of a struggle. Yeah, I lost you for a good 5-10 seconds.
Okay. Uh, Alex, I think have you done a lot of, I thought you have done some work on this. Did you have any thoughts?
Yes. Okay. If you kind of trigger me like mixed feelings, because so what you try to convince your audience that so let's suppose everything's slow. It's not a slowness of Solo, it will be slowness of consensus node, obviously. So if EVM test runs slow, it's consensus node. If something starts slowly, it's consensus node. There is nothing against Solo if something goes wrong. That's my point.
Oh, no, maybe Alex, let me tell you exactly what I'm trying to test. You're right. If you want to compare local node versus solo, consensus node time will be the same. Mirror node ingestion will be the same, but there will be a difference around the time it takes for a transaction to propagate from consensus node to mirror node, because local node
But
uses
but
record
you see,
stream.
but you're looking at something that doesn't exist when local node dies in a few months. And so you're
Uh,
not if you turn turbo
let,
mode
let,
off, then
let,
it's apples to apples
let,
because you're
let,
you're
let,
leveraging a feature that doesn't exist.
Yeah, let me just finish my sentence. I'll explain that part. So like that's where we're gonna have the major delta. So like round trip on local node today with turbo mode with record streams is about 500 milliseconds. And round trip, when I say round trip, I mean the time it takes to submit a transaction to the time it appears in the mirror node is about 2.5 seconds. I mean, which is like our normal kind of propagation time. Now, you're right, like that. Now, but with it will become apples to apples with record streams, with block streams. But actually, the block node team is saying that there are things that we can do, and we're going to have to test this to lower that propagation time with block streams. Like we can like do one transaction per block and all this kind of stuff. So we're going to need tools to be able to measure that and quantify that. Um, about the that test run time when we have block streams, because we're going to have to play with different configurations of block streams to try to, and you know, the ultimate goal is if local node today supports a 500 millisecond round trip, eventually we want, you know, at a minimum, we want Solo with block streams to support a 500 millisecond round trip. However, we have to configure it to do that.
Yeah. Well, it is I would say it does have value of a conversation that we probably need to address, and I don't know if we can what we can do, but we definitely don't want to lose sight of it. It is important, but we've also got a lot of other issues to address. You know, it needs to go through the A5 program. And get prioritized so that because
Jeremy,
basically
Jeremy,
the whole the
this is
A5
not
program
this,
owns the whole solo team that's not, you know, community. So
but Jared, this is not a work request. My request is this is a conversation about like I don't think I designed the synthetic test properly.
okay.
What would a good synthetic test for this look like?
Which part are you focused on? Because you have six of them, and I lost you for 10 seconds or so earlier.
Yeah, so maybe we can just start with the how we test a happy on Solo, like a synthetic test for happy on Solo, and how we do a synthetic test on EVM for Solo. Like what would be a good way to measure test performance on Solo?
So on the happy, I mean, when you're doing write transactions, they should be going directly through the consensus node. And so you should see on write transactions, you know, depending on what's happening, you should see something very comparable. On the read transactions, it's going through the mirror node, and that's where your turbo mode is going to give local node an edge. And so you should see that show up there on the reads. And then if you're also if you're leveraging the relay, then you're going to see that same thing because the relay it's basically going through the mirror node, so you're going to get advantages of that turbo feature of the local node. The
Yeah,
EVM test
yeah,
runs, huh?
maybe you missed that part of it, Nathan, but like, or Jeremy, but like, so these tests are designed. I mean, a customer test almost always writes a transaction and then waits for it to appear in mirror node to confirm that it was successfully it succeeded, right? So that I mean, that's the nature of customer tests, and that's what these tests try to simulate is the what I use called the
Mhm.
round trip, the submission of a
Oh,
transaction,
okay.
and then for when
Yeah,
it
yeah, yeah.
appears in the mirror node. So it's both, right? It's write and read, because that's, I
Right.
think,
Yeah, yeah, yeah. I
what
got
most
you.
customers do when they run synthetic tests.
Yeah, so earlier in Solo, whenever we had configured everything, we just configured it with the consensus node without the mirror node. And so it was like super fast because when you configure the SDK connection for a consensus node with no mirror node, then it uses the consensus node to also do the read transaction. So you bypass all that. And that might actually be a hack for us to look at potentially for certain circumstances to speed up the net effect. But the EVM, a lot of the EVM stuff is designed because it's, you know, Ethereum and the way that it works and all of the Ethereum clones. They basically leverage the that gRPC web. Well, not I don't even call it gRPC web. It's just it's basically a REST interface sort of. And so the relay gives them that capability. It bridges them. It's a bridge. And so the relay is, and you know how all this is working, but because you're going through the relay, of course, it's going to force that to, leverage the bearer nodes for all the reads, which is, to your point, part of the transaction response that it got written. So
So,
you have that additional hop of the relay though, but it should be negligible, but it's still there.
no,
And it
oh
would
no,
be both for
it's
local node and solo.
it,
So
in my test, it is significant. Like it's a big difference between the EVM test run and the happy test run, even though they're basically doing the same thing. But again, I think the question is, what should the design of a synthetic customer? We want a test that simulates what customers do with Solo. And so what should that synthetic test look like? How should that synthetic test be designed? Or the way I called it, like these are benchmarking tests. What would a transaction benchmark test look like on Solo? And that's the kind of because I think Oleg and I think also you, Alex. I mean, Alex, have you done work on that in the past?
Yes, I absolutely, I'm there. So one more point. So, Keith, I'm permanently like I'm hearing the statement that Solo makes things faster. So let me kind of clarify that. Solo is not making things faster. Solo enables what was impossible before. That's a huge achievement. Thank you for Jerome. So Solo does not make consensus not faster or test faster, not
Oh,
making faster.
I never said that, Alex. No, like
Okay.
it
So
doesn't make anything faster. No.
yeah, the great thing is Solo
it
makes
does if you
things,
compare to testnet.
yeah, make things possible what was hell difficult before with command line things. That's what the statement. Okay. In terms of performance tests, so recently Jerome's team introduced this plugin for Solo that enables NLG network load generator. And people can start, for example, in terms of EVM, it may be HeliSwap, smart contract, or any other general like NFT transfer or crypto transfer things. Yes, that's a very good kind of paragraph to tell people that with Solo we can run standardized performance tests. That's a very good kind of statement, I would add. One of the example is EVM, of course.
So in your performance tests, what do those like? What does that synthetic transaction look like? Like I said, I built a synthetic transaction that like creates three accounts, deploys a smart contract, creates a token, mints a token, and transfers a token. Like that's the begin and
Well,
end of
see,
the
as
Exactly.
test.
it,
Exactly. And now the
if you just
standard,
put if it, you take network load generator and point it, I mean, it's built into Solo, but it's just a flag, a command to launch it. But you could go ahead and do that, same thing and point it to local node and then compare them. That would be interesting. That would be a really interesting step.
correct. NLG is already part of Solo and just run, for example, HeliSwap. It will report some numbers, something about 1,000 transactions per second on large machine and something about 300 transactions on laptop grade machine.
Okay, I didn't. This was the kind of information I wanted. I didn't know that we had a load generator plugged into Solo, so maybe I can ping you guys afterwards and get more information about that.
Absolutely,
Because
yes.
yeah,
Yes.
I would
And
love to.
we have five tests for like all possible kind of scenarios, which is NFT transfer, uh, HCS, crypto transfer, HeliSwap, smart contract. It's just satisfy everybody's benchmark needs.
Okay.
Yeah, and you could put it in the Solo channel, um, and that way Alex can see it there too and help chime in because Alex knows a lot more about NLG, even though we've plugged it in, but he's a lot more involved in it. So
Okay, that's amazing. I mean, if it's already built, then that saves me a lot of time and energy to try to build it myself. So that's wonderful. Thank you.
And one more time, sorry, I'm kind of annoying here. Your statement about shutdown time, start time, let me ask my question again. What you try to achieve in these statements, so to speak? Because my point is, it's whatever time it takes Solo to shut down, it's taken. It's unavoidable. There's nothing we can improve here. Or startup time, it's given. We cannot improve or accelerate it. It just
Well,
expenses.
so Alex, yeah, there's a lot of conversations, Alex, that you're not part of. But
Probably
one of
I'm
the
out of
things
sync.
is that we're yeah. So and it's it's not tied directly to your work, but you will probably get some benefits from it. So basically because of TSS coming along, then local node's going to die a horrible death and not be able to upgrade the to any future version of consensus node past 72 or whatever that number is. Um, and so basically we need to get Solo up to par so that whatever the community that is currently using local node instead of
Jeremy,
Yeah, I think Jeremy dropped again.
we lost you. Okay, I already got the idea what Jeremy want to say
Well,
about.
I'll just show you something quickly, Alex,
Uh-huh.
just so you get an idea of what it is we're talking about. So like here's the numbers that I've been running. So like this is doing comparison of solo versus local node. So you can have different metrics like
and then
startup.
likewise, a team has to spin it up and run it inside of their workflows or whatever, depending on if it's GitHub or GitLab or whatever system they're running. And so they need to do this in an efficient way, and some of it is kind of sort of there, but some of it there's some opportunities, and we have some features that we're like about to you know try to get out at breakneck speed that will allow them to, like, once it's stood up, then it will allow them to basically just drop the ledger data, and restart Genesis without restarting everything. It just only restart the consensus node GVM, which takes about 45 seconds. And then of course the Mariner importer has to sync back up too. But and so we don't know what the times are yet on that, but it should be pretty fast, hopefully. And that will allow a kind of a warm start-ish, like if you already have the network running, but you finish the test and now you want to reuse that network, that'll be a quick turnaround. So we're going to call that maybe like solo I don't know, it's consensus ledger or solo ledger. I think it's solo ledger reset, maybe. I don't know. Like I think we do 3 commands deep. So whatever it is, but we're just calling it ledger reset for short. And then there's another thing we're going to do basically is caching. And so we've been talking about this. We actually started this conversation a couple months ago with Hendrik and some of the stuff we were talking about and some of his stuff that he's been communicating at like hackathons and some of the workshops he's doing and stuff. And so like basically what we're looking at doing is creating this like cache that's going to have all of the container images, all of the Helm charts, all that stuff. So that basically, and it'll pre-install all of our, cube control and all that stuff. So it's not pulled while you're in the middle of running. And it will have it already there so that you avoid all that very lengthy time of download. And so a user can go in there and run like brew solo install or npm install, whatever. And we will have to figure out how we're going to do this, if it's going to be at two different versions of install, like one's with the cache and one's not the cache, because like you may not need the cache for your stuff, Alex, because you're customizing a lot of the versions and things like that. But anyway, um, the goal is that if we have all that stuff sitting there, then we can just inject it all into the cluster, and the Docker or Podman or whatever is running, so that whenever the cluster is loading those resources, they're already cached, they're already being used, and very like some of the other teams that work with Solo and other ways already leverage a lot of these concepts, but it's not built into Solo. They're kind of like doing things behind the scenes at an infrastructure level to trigger this. So that there's some things that we're doing that will speed up the start time. It'll speed up the warm start, and it will improve the reset between test functionality. So yeah, so we're working on that. to you, Keith. Like we just had a lot of conversations today about all of that, and to you, Alex, so that you kind of are looped in. Yeah, but yeah, Keith. Like one of the things that is that what you're like local node's great in some ways, but it also gives you a false impression because when you're running turbo mode, then what's happening is that you're seeing an instantaneous feedback between whenever you submit the new thing from consensus and then you receive it over on the mirror node side. But like whenever we were running, we didn't notice it at first. I mean, it was occasionally failing the solo test because we don't have turbo mode, right? It has to actually go through the more proper way that reflects testnet and stuff. But you know, whereas with turbo mode, you're like it's writing directly and reading directly from the file system, so it's like instantaneous, pretty much. Um, well, what happens is like when we switch to block node to mirror node, it increased that delay and lag. And it started to surface some really weird things. Like if, say, for example, if I go in there and I subscribe to a topic, and then I wait, and then I go in there, and after I subscribe to the topic, then I post a message to the, or actually, let's say I subscribe to okay, wait, I create a topic, and then I subscribe to the topic, and then I put a message on the topic and wait for that message to come back on that topic, right? So this is using you know, the what's it called? HCS? I forget the name for it, but the messaging system. And so what was interesting was the tests were passing. It would randomly fail. We weren't sure what was causing it, but it wasn't that big of a deal because the random was pretty low. But when we added it and said like, okay, we want to use blocks mode, or we was configuring mirror node to use block node, and so you had like the block node in the middle. It was the middleman, which is how it's going to run later. But it's still not heavily supported yet. They're still working out those features. Um, what was happening was that you would subscribe, we would create the topic, but when we ran the command to subscribe to the topic, it would fail. Like because mirror node got the request, but then it wasn't there. And so the SDK probably like maybe returned an error, or it got an error like resource not ready or something. I don't know, but it kept like hanging, like it was still looking for it, but it would never connect correctly. And so I think there was maybe some bug there too, but essentially it would essentially not work. And so the way around it was like, okay, we create the topic and then we wait until it shows up in mirror node, and then we subscribe to it. Like it has to be there before we subscribe to it. Okay, well that makes sense. Kind of, yeah, okay. And so then we would say, okay, we're going to put the message in there. Well, we have to make sure that we found out we had to make sure that the subscription was actually there and active too before you put the message through. But then you had to wait for the message to show up. And so there was just these things that like that if you were like, it just made me realize is that when you're using that turbo mode inside of the local node, then there's logic there that when you move to testnet, it's not going to work. Like it's just you're making assumptions that are not real, and because things are happening so fast, it looks like things are going to work, but then it doesn't. And so, in a way, it's actually creating unhappiness. Yeah, whenever they move from local node to testnet, because it doesn't have the same reality, right?
I kind of get you, but Jeremy, like this is the standard for like if you take like Ethereum test networks, like they work at like 1,000 times the performance of the actual Ethereum L1. So you use those frameworks for like testing functionality. You don't use those
Yeah.
frameworks for building out production applications. I mean, based on timings, like
Yeah,
you
yeah,
cannot use
I
if
understand, and I'm not saying that we don't. But see, like one of the things is that like in solo, we're actually building solo to be a production environment. That's the difference. Like local node's not meant to be a production environment. Solo is. Now we're gonna build bells and whistles in Solo. They can allow it to go run in a way that will allow you to do, hard hat and foundry development. Yes, we're gonna develop that and we'll get there. And hopefully we'll get there really fast. But you have to realize that we also have, in a flip of a switch, the exact same tooling can now be ran production mode, basically. Local node didn't do that. Like local node did not design that.
Yeah, I understand. I think the reason why I think we need synthetic tests is because, as I said, I think specifically for the implementation of Solo, for the config of Solo for certain applications like hard hat, we are going to have a different configuration for block nodes and block streams that would allow faster round time performance. So we need to, but we've not tested it yet. So we need to test that config specifically for those type of developers.
Yeah. Okay. So yeah, put that request of about more info about AMV or whatever, or look into it, and if you got questions. The solo Slack channel to start you off with, I think is a great way to get some quick feedback and also make an opportunity for others to kind of like learn from the conversation. Because I mean, you didn't know there's NLG built into Solo, because it's not been widely advertised yet, because we built it for a small subset and a small set of reasons. But eventually we'll get around to stocking it in the future more. But yeah, so there might be other people that want to leverage it too. So
Yeah, that'd be great. Yeah, so that was the main topic I had.
cool. You good, Alex?
Yes,
Well, it's
I'm
treating
good.
you good, it sounds
And
like.
again, let me repeat for Keith. So Keith, I recommend to use Solo version 0.55 because very important feature was added. It's ability to add system environment variable to Java process of consensus node. Thank you, Jeremy.
Oh yeah, the application ENV stuff. Yeah. We need to get that better documented too. I have it in my massive list. We're in a bit of a craziness right now about all the stuff that we have to do all at once. But yeah, so with application ENV, you should be able to pass any sort of JVM parameter that needs to be picked in up by the consent. So. And it should be working. And we have an example. I did add an example though. So that's in the docs. Can you still hear me? Sorry,
yeah, we can still hear you. I'll just share one other thing while I'm here, just because I have, I've been running Solo and testing it. Because we always have this conversation, but I was just on memory consumption. So this is just my own personal computer. But yeah, I mean, is this what you guys, because I know we always have different numbers right now, but on my personal computer, it did start at about 8.5 gig, but this has been running for about 6 or 8 hours. So it did over time go up to about 9.3 gigs on my computer for running Solo. Is that what you guys are seeing as well right now?
It looks
yeah. So we actually
Jeremy.
Go ahead, Alex.
Okay. Yes. It looks what was I observe.
If you have something to say, go ahead. We get it down to something like 8 gigs, I think, by less than 8. I think it's like less than 8 or less than 4. Maybe it's less than. Maybe we have to get down to 4 gigs by the end of Q2 or some craziness like that. And then we have to add TSS and get TSS down, but it'll bring it back up to 8. But that's TSS really. It's with wraps that adds it. I think if we just use Schnorr's algorithm with TSS, it's the new signing for the blocks and everything for people listening in later. Then I think it's less of an ideal. But we're working. We have a huge agenda on the memory. And to answer your question, yes, it is. It's less than 10 for a 30 minutes performance test running NLG. And I mean, if you keep hammering it with transactions and stuff, you do see a very consistent but slow gradual increase. And unfortunately, because a lot of these are running JVMs, like once they grab the memory, they don't release it. It's just the way JVMs work. And so once it hits you, you very rarely, depending on which application is causing it. I mean, consensus node is written in Java, the blog node is written in Java, a lot of the mirror nodes written in Java, and what's not written in Java, they're converting to Java, and all of that is basically the concept of a JVM, which when it grabs memory, it doesn't release memory even when it's not using it. So.
So Jeremy, yeah, this is not so much about the roadmap for memory footprint reduction. This is a question about I'm trying to understand the current behavior of Solo for memory. So what I saw was that, yeah, it started at about 8.5, and then very quickly it went up to 9.5. And I didn't, that was without me doing any transactions. It just seemed to naturally grow on its own without submitting any transactions to it. So I'm just trying to get a statement of reality. Is that the behavior that today are we? And this is like using like the latest version of Solo. Is that the behavior you guys are the memory behavior you guys are seeing on Solo today? And it's not about the future. Like we're going to work on it. We're going to improve it. I'm just trying to understand what does it look like for you guys today?
Yes, correct, correct. So even if you're
Yeah,
not,
it's a part. Go ahead, Alex.
yeah, technically speaking, if you not issue your own transactions, it automatically send transactions just 0.015 units just to keep it alive. And state, it's always growing. So what you see is correct.
Well,
Okay.
you used to see that less with the before block node, but and I also I think actually you're probably seeing if you're running one shot, you're probably not activating block node because by default it won't activate block node. But the consensus node what you're probably seeing is I don't remember I don't remember if we have the TPS pinger on the mirror node monitor turned to 0 or not. We may or may not, I don't know. But if that pinger is on, it creates a small lightweight set of transactions. um, but it's probably the gossip because the consensus nodes gossip even when it's idle. So that might be what's driving it is just the gossiping because they're basically just talking to each other saying, "Oh, do you have any transactions? No. Okay. Do you have any transactions? Nope." So they're just kind of keeping the network running. And so that's probably building up just a little bit of activity. So but I think there's opportunity there too. Like this whole initiative that Solo is needed for Solo, and because local node is going away, I think it's going to improve the better all of our products, right? Because a lot of this is not Solo. A lot of this is the components within. It's mirror node, it's block node,
So,
it's
so
consensus node, it's
yeah,
relay explorer. It's all of these components. It's
yeah.
very little of it in Solo, but we get because of what
I've been
we
highly
have, we
involved.
get all the attention. We're going to be driving all of those other ones to be better.
Yeah, I've been highly involved in the memory footprint conversation. So it's not so much about what we're going to do in the future and the benefit. So what struck me as curious, which I'd like to understand, is that again, it's because I knew that Solo was increasing over time, but I heard that had come under was not happening. But again, on my computer, so I get gossip and everything. I guess I'm still surprised that it starts at 8.5 and goes to like 9.5, 10. Like gossip would not add a gig. Something is adding a gig as you run it like over 20 minutes. And I'm just curious what's adding a gig to memory footprint. Because to me, that's a very curious behavior.
Yeah, I don't know specifically without like diving in and seeing. So are you just running one shot and that's it?
Just one shot, yep. Just a one shot deployment. So it's
Okay.
very weird. It's very weird to me that because yes, we're gonna at startup, we're gonna if it's 8.5 today, we're gonna work together and reduce that down to 4 or whatever. But if there's behavior in Solo that causes it to like increase by a gig in 20 minutes without submitting any transactions, then that's a behavior that I think we need to better understand, is would be my perspective.
Yeah, yeah. And the consensus in the mirror node team could probably tell you because the block node is not enabled by default on the one shot. So yeah, so maybe they might have to work with them, but it may or may not be a configuration that Solo is leveraging. I don't know.
Well, the question would be, I don't think I mean, I'll run some tests. I don't think local node grows like that in memory foot. But local node is using the same consensus, not the same, but like a similar consensus node version, a similar mirror node version. And I don't think it shows that
Why is
same
it not
memory.
the same version? You said it's similar, but not the same.
Oh, because local nodes pin back a few consensus node versions. Like, it's not, they won't be using the same consensus node version. But
Well,
I don't think,
You can tell Solo to use an older version so that it's apples to apples. You have to use Falcon to do that.
sure. Okay. But my point being that regardless, I don't think we see the same memory profile. No matter what consensus node version you use, I don't think we see the
Well, I
same
think
mem.
like if you're running metrics and you're sharing with people, you should probably be using the same versions of mirror node and consensus node. I think that's probably actually very important.
Okay. Okay. Yep.
Okay. All right. Well, I guess do we have anything else for this call?
That's all I had.
No. Thank you, Keith. Very interesting report. Very,
All right.
Thank
very
Thank
you.
you,
good.
guys.
Um, we'll be working on lots of things that hopefully will benefit everybody. All
Cool.
right.
Thank you, guys.
Thank
Bye.
you. Bye.
Oh, I just saw. Oh, she already dropped. Dang it.